Hello again, my friends. Welcome to MTD CNC North America. I am at Harbec today, and I have a really great honor to spend time with my friend Bob. Now, I usually make some introductions based on having some sort of insight about the product or the technology or the information that I'm about to share with you guys. But Bob is one of those types of people that has mindset to really understand processes that I would like to learn more about. So I'm on your team today where we're all going to get to learn. So I'm excited about this. So Bob, Harbec is really unique in itself in many aspects. And we have lots of machines and we've talked about growth and what you guys have grown into. But there's something that we haven't talked about today, which we can kind of see in the background here with windmills and natural energies. Could you please explain and expand on that a little bit so that our global audience can learn a little bit about how you guys are creating all of this energy?
Well, it starts out that we are, with logic, we are a huge user of energy. Industry is one of the most significant consumers of energy, and so if you want to do something about that or use it to take an opportunity to help yourself, there's great potential in it. So if you're using a lot of something and you can figure out a way to use less, it's a positive thing. So at that simple level, all of the things that you basically quickly touched on and those you didn't are all economically driven. There is an ROI or economic model that justifies each one of them, and they have been implemented and developed over the last 20 plus years now. So in the late 90s, we started by having problems with our local utility. And we were, and this is the time too when the CNC machines were getting pretty sophisticated, doing some very amazing complex cavity work and things like that, high precision. And we had a grid that would, for the general public, be no problem, but for us it was a problem because it was poor quality of grid power. And so brownouts, low voltage, phase imbalance, all these kinds of things were becoming more and more prevalent, and then the result was more and more damaged equipment, computers and CNC machines. So we tried to work with the utility to improve that, and they basically don't deal with one customer. And so after a lot of frustration and lip service, they gave us a solution that would allow us to pay $100,000 for a transformer that they would own and they wouldn't guarantee would fix our problem. So my situation was I have a $100,000 outlay that nobody's guaranteeing will do anything, or do I go find some better way to use that $100,000? And so that was the core, the impetus to make it all happen. Parallel to that, I had always been interested in renewable energy before they had the word, before people knew about it, in that when I was a kid, I was always infatuated with the magic of it. So the pull of a kite string, and the bigger I made the kite, the harder it pulled, and that invisible pull, the ability to do wood burning with a magnifying glass, nothing else. And so I always had this sense of magic about that invisible thing. And so in my younger life, I implemented wherever I could those, at that time, brand new technologies like wind turbines and solar panels and that at my home. And I am lucky enough to have a farm out in Webster, and so I put up my first wind turbine in 1980, which was a newsworthy event because nobody had ever heard of that in 1980 at home. And I did a lot of work with geothermal and all kinds of the alternatives that I could find. And so I had that experience and sort of like a passion behind me when I had this problem with the grid. So I decided to see if I could try to solve some of those problems that I needed a more intelligent way to spend that money on. And that began it. And at that time, so now you're in the late 90s, there was not a lot happening in the United States. It still isn't really, but there was a lot starting to happen in Europe. So I was able to find examples and learn from different situations that were happening there, and learn about things like combined heat and power. And so as I sought to find the solution to the power quality issue, I became exposed to another whole level of opportunity, which was the value of total energy. So that the potential for combining energy efficiency and energy renewability became a combination that we put together. And so the first version, the first project that I tried to bank was to do a micro turbine combined heat and power plant along with a renewable energy wind turbine. We set out to do it, got financing, but at that time microturbines were at the very infancy. And so there was a lot of smoke and mirrors and false statements and that. So when we got our approval to go ahead, we ordered the first group of microturbines from a company, and they refused our order. Then we went to the second group of microturbine potentials, and they refused our order. And we went to the third one finally, and they could honor our order, but they were telling true pricing. The other two were not. So I had a dilemma. I had to go to the bank, explain the situation. I was lucky enough to get NYSERDA, which is New York State Energy Research and Development Authority, to help me and loan me money, but mostly they loaned me their name, because when I could go to the bank and say NYSERDA is helping me, in New York State that's sort of like an unofficial seal of approval. And so the bank recast the loan, said, but you can't have the wind turbine until we make sure about this. So we started out with micro turbine, combined heat and power plant. We ran 18 months, 100% off of our micro turbines. No, we stayed connected to the grid, but never took any power from it because we didn't want to lose our hookup. And then after 18 months, we were revisited by the bank, and they said, you can go ahead and do the wind turbine, because it was working so well with the microturbines. But from that, we already knew the opportunities of a wind turbine are pretty simple. So as long as you know what your wind regime is, and you can predict that very accurately. Nowadays, it's a very bankable number. You do a wind study of your location, and the bank honors it because it's proven technology. The same is true with solar. And you can, from those studies, you can predict plus or minus 10% per year because weather is consistent on an average. And so from that ability of gaining wherever the wind is blowing energy to another opportunity, which is the efficiency of combined heat and power. And that's a really huge one, and we learned a tremendous amount. So the obviousness of renewable energy, but the amazingness of combined heat and power. Because we learned that as a starter, when you go home tonight, and I don't know where you live, I don't know what your utility is, but I can tell you based on the national average, that when you turn on your kitchen light switch, at the moment that that power gets to your switch, so now you decide how to use it with LEDs or compact fluorescent or smart appliances. At that point, 75% of the potential energy, so whether it's nuclear, coal, oil, natural gas, doesn't matter, but of all, whatever the fuel that was used to make that get to your switch, 75% went to waste before it got to your switch. That's based on national average. And most people do exactly what you're doing right now, and they think I'm full of baloney.
I don't think you're full of baloney. I'm curious
correct.
Why.
That's the best question. I usually ask you that. Where do you think it goes?
Don't know.
It's heat.
Okay.
Most, well, if they guess it all, they'll guess line transfer loss, so sending the power out over the lines, and it does lose a small percentage, but by far the majority of the energy, so 3/4 of the energy is wasted in thermal energy. So why do you think all the utilities live on lakes and rivers and or have those big inverted chimneys behind their house?
Mm-hmm.
Because they have to get rid of what they call waste heat.
Mm-hmm.
But it's only waste if you're stupid enough to waste it. At Harbec, we use that heat, and that's what the combined heat and power means. We use that thermal potential, and we like to call ourselves thermally enlightened.
I like that.
And so we find every way we possibly can to use that 75% up. At Harbec, if you flip on a light switch at this point in time, we're between 80 and 85% BTU efficiency. So we're still wasting 15 to 20%, but we have pages of ideas of ways to even use more of it. And so how do we use the heat? What are we going to do? How we make heat? I mean, it's counterintuitive, but the answer is there are no furnaces, boilers, or air conditioners at Harbec.
Wow.
We use the thermal, and they were, so all of those devices over the years have been recycled. And as we grew our awareness and ability and opportunity for using thermal more completely, so now we have all of, except in this part of the building, the original part, but every other place where we build a new addition since the early 2000s, we put thermal tubes in the floor. So that's a very simple one. We add heat to the floor. It takes almost no energy to put the hot water in the floor. And I guess I should start there with the hot water. So when we run our micro turbines, we get two things from them. Every generator, even wind turbines, when they make the electricity, they make a second product, which is the heat. So rather than pushing it into the lakes or rivers or chimneys, we take ours to a heat exchanger. So we take the hot exhaust gas to a heat exchanger, which has tubing running through it. As it passes through a tortuous path, its thermal energy is put into the water. So all the time we're running our micro turbines, we are creating a thermal potential. And so that thermal energy then is delivered in the form of hot water to different jobs in the company. The simplest one is the one I was just talking about, to take it to the floors. The next level up is where we already had existing furnaces and boilers and air conditioners. We take them to heat exchangers. And so rather than having a furnace at a place, we have a heat exchanger. And the heat exchanger is like a furnace blowing the hot air across the heat source and heating the space. Except the heat source is not a consumption of fuel. It's taking the exhaust heat and bringing it up to that location. And then the really dynamic and coolest part of all is we also air condition our whole company with the waste heat, or the waste of the microturbines, the thermal potential. And so again, we take that constant supply of 200 to 220 degree hot water, and we deliver it to a very interesting technology called absorption chillers. And absorption chillers are phase change devices. So in our first one that we got when we built our initial system, we were able to take that to that device. So it's a big, huge, long barrel full of tubing. And in the tubing is either the water loop or lithium bromine loop. And lithium bromine boils at about 160 or something like that. So if we're putting in 200 degree hot water, we're able to create a boiling refrigerant. Lithium bromide's a refrigerant. So doing the phase change, I'm not a thermodynamics engineer, but I know the basics of it. They are able to boil the lithium bromide. When it evaporates, it causes cooling. So the end result is we put 200 degree hot water in one end and we get 44 to 47 degree, which is the perfect temperature for air conditioning, for dew point and all that, out the other end. And so now we take that cold water and deliver it to these alternatives to air conditioners, and we air condition the company. The interesting part is the company that I'm talking about is air conditioned and humidity controlled then with the waste of making the electricity that we need. So we have, as an injection molding company, a very unusual thing. That is, we vent all of our molding machines to the outside. So every melt chamber on every molding machine has a 6-inch duct that constantly pulls the air out of that so that we don't have the normal. So when you were in our injection molding plant, did you notice anything? Did you wonder if any of the machines were running? Because if you've been in one before, you have a soaking smell of melted plastic in there. There was none. Did you notice that they weren't screaming at each other? Because we use all electric injection molding machines. We have no hydraulics. The reason why, so now you get into the rest of the opportunities to think about energy. So not only how to use thermal to your advantage, but now we have developed over the years a mentality about purchasing our equipment. And I mean the fact that, do you know that Robo is regenerative?
I did not.
The Fanooks have the ability to do regenerative braking in machine tools. So when they're slowing down at a high-speed move, they actually make electricity and put it into capacitors. But we look for that kind of thing, and all of our equipment purchases are not just the best economic value or the shortest ROI, but when we make our ROI decisions, there also energy is included into it, because it costs energy to run that machine, and often when we make a decision, it's a little bit more expensive than it could have been, but we can justify that extra expenditure within a couple of years at the very most, just in the energy that's saved. And typically when energy is saved, there's also less wear and tear, less heat, less all those things, but we don't add that in because we can't tell for sure. And then we put that into our ROI decision, and as long as it's within a couple of years, we make the decision to buy the more efficient, but maybe a little bit more expensive machine. And that way of thinking we try to do in all of our equipment. And again, we were taught that by NYSERDA, who until the last few years had a program going where they challenged companies to give them a solution like that, that if I bought this compressor, I have to pay a premium, but the energy that I'm saving for a few years, and you would document it, they would come in and measure before you replaced the piece of equipment or purchased equipment where you were. Then you'd bring in the equipment and they'd measure you again, and then they would verify that, yep, you are saving that much energy, and they would reimburse you whatever their percentage of benefit they were giving you. So we learned a lot, and it became our modality for equipment purchases. So we have the energy generating potentials, the energy efficiency potentials. In that regard now, because of our changeover from just thinking of them initially as electric generators to fix our power quality problems, they have now become thermal generators, and the electricity is the byproduct. And so if we keep that way of thinking, as we learn through the different phases of it, regardless of the cost of the fuel for them, it will always be our most cost-effective way of operation. And the reason why is because of the consumption, the totalness of consumption. We don't have to worry about if the price goes up and we're using it only for thermal, then we only use what we need and we get the electric another way. And so that whole combination of ultimate efficiency and ultimate renewable, the opportunity of renewable, is how we came up with a total solution.
Well, Bob, I'm in absolute awe. I got to be honest. I'm in absolute awe of what I'm learning from you, and the information and you as a person. A couple of follow-up questions, just based on listening to you talk. Uh, you mentioned that you tinkered around as a kid and you had your, playing with the sun and being able to burn things, and, the kite with the long string. So one of my two questions is, it feels to me like it's more than just a curiosity. Like you have a real passion for maybe doing your part to make the earth a better place and not destroy, some of our older resources. And the question after that is, how doable is this for other companies to accomplish as well?
It's incredibly doable. There is nothing that was invented here. Everything is off the shelf. But you touched on something that I wouldn't mention unless you did, which was there is another reason for me for all of this. But in the very beginning, I made a very bad mistake. And I led with that reason. And I, for a number of months, had terrible failures in trying to bank what I was thinking. And the reason why I was inadvertently branding myself as a burned out hippie or a Birkenstocker, because I was telling about my heart that was behind it, about my grandchildren, about the future of the planet, about all those things. And they would sit in the room and listen to me, and I thought they were engaged, but then within a day or two I'd get a rejection. And just not able, no proof of concept, all these kinds of vague reasons why. And one of them finally was honest enough to say, I can't sell my committee the things that you're saying, and I realized I needed to stop that. So I went back underground for another few months, rethought the whole story, and decided to focus on economics. So now my opinion, based on my experience, is that if I want to make an impact, I have to prove it economically. It doesn't matter what I think about the future or the environment or anything else. If someone asks me, I'm very glad to go into great detail about why I think it's important. And as an example, Harbec has been a carbon neutral company since 2012. We are one of the first companies to become ISO 50001 certified. We are platinum, and I believe we're one of only 8 to 10 companies in the world who have that level, the highest level of performance, and certainly the only small company, at least at our last checking. And so it isn't just us that cares about it, and I believe we are developing a marketing strategy that unfortunately we're in the wrong place and perhaps at the wrong time, but that it's coming. And by that I mean sustainability in the United States is a term that's very popular for the sake of discussion, but not for the sake of implementation. So if you look at the majority of, every Fortune 500 company now is putting out their sustainability statement. That includes Exxon, Shell, the coal companies, everybody like that. They all have a sustainability statement then. So what exactly is sustainability, and it's just the same thing with green at the time of that term. And so they're kind of empty buzzwords that everybody jumps on. They all want to have it there so that their stockholders and customers buying products off the shelves will see that they are conscientious, but it's in, majority of it is in name and word and hopes and plans and ideas for the future. Do you want to know what Harbec's sustainability report is?
Do.
We are carbon neutral in 2012, water neutral in 2015.
Impressive.
And that's it. We have done that. We will be zero waste to landfill by 2025. So they're very simple provable. We get third-party audited every year we put ourselves up for that, though. And that's because we want to be able to prove to the customer who someday challenges, because we also, when we quote jobs at Harbec, we quote time, material, like everybody else, and carbon. And so we show the customer who's making a purchasing decision, that's the price, and this is how much carbon I can take off of my carbon footprint if I buy the part from Harbec. In the United States today, nobody really cares. I mean, I hate to say that they don't, but I can't get proof. I look at the companies, the big companies who are making all the claims, and try to get to them. We have tried and failed so many different ways, and the closest we've got is they'll tell us, no, we aren't in our supplier base. The same mouth that just said our supplier base isn't performing the way we want them to. It's like saying, well, then can't you put two and two together and say, take us in front of your suppliers and say, well, now we're going to give work to Harbec if you don't do it. But it's not happening.
Well, for what it's worth, it matters to me.
Yep.
And I'm not a large company like the Exxons or whoever else you mentioned, but it matters to me, and I think it matters to a lot of other people as well. So let me say thank you for that, first of all. And the sustainability that you're talking about, it sounds like a fun keyword, but I think it, to most people, it just means financial stability. Yeah. I was talking with a couple of your teammates earlier, Chris being one of them, and he took me out to a pond that's actually empty right now, and it looks like you're implementing a new process there, which I'd like to talk about. But also he showed me some reinvention of some plastics and the same concept of how we're trying to bring some of the coral reefs back to life. Would you mind talking about both of those things?
Sure. Our pond is a big part of how we were able to become water neutral. And there is no, in carbon neutral, there is a term that everyone understands. Water neutral, we made it up. And why we did is because we learned from carbon neutral about taking responsibility for carbon, about doing metrics, about your impact and all of that. But I have a passion about water also. And we, in our area, we are so blessed to live on the largest supply of fresh water in the world. And so therefore we completely ignore it. We just totally waste it. And it's so stinking cheap, nobody cares about it. But the rest of the world, there's some major, major issues. And we have a sister company who is involved in that. So there's a special level of passion about it. But industry is also a huge user of water. And we, as a typical industry company, initially used it the same way as everybody else. But one day we were given an opportunity to do a conservation project, and it included rainwater harvesting. And so we were able to divert all of our, well, actually we were forced into it because our town did not have an adequate water supply to our company to run our fire suppression system. And it became our insurance company's law that you had to have it. So we had to come up with some way to get enough water to run the system. So that and the opportunity to do rainwater harvesting began our pond. So we needed a source. My son is an excavator and does ponds and other things like that. So he estimated he could do 900,000 gallon based on the depth of the bedrock and the area that we made available to him. We commissioned him to dig the hole, and we diverted all of our parking lot runoff and building roof runoff to that, which we were able to estimate from some environmental engineer friends of ours was a 1.2 million gallon, again plus or minus 10% with weather, potential per year. So we have a 900,000 gallon hole and 1.2 million gallons of potential. It's a good balance. Mm-hmm. And so we were able to sustain a pond. And then once the pond is in place and we have our fire system in place and all that is satisfied, an opportunity came about saving energy. And so being this thermal enlightened that I was joking about before, we said, and we know we have this process loop that we're constantly running to cooling towers, spraying perfectly good city water, which I call energy water. And the reason why is because energy water is not like pond water. It is water that was taken from a lake or a river, run through a treatment plant, pumped back out, so a lot of effort and energy went into this, making this water that we completely take for granted. And so that prime water or premium water is what we use to spray on aluminum plates and with hot water running through them in what's called a cooling tower. So when you go by plants in the summertime and see the big plumes of steam coming out, you know they have those same things. They're doing the same operation. But the water we're spraying on those is this energy water, the prime water. And so we began to think of how good ways that we could reduce that amount of water that we have to spray on those plates. And one way was to, and again I mentioned I had geothermal experience, so we thought about the pond as a geothermal potential. And so we had some heat exchangers that in our earliest version of our combined heat and power plant had failed. They were a low quality disappointment. So we designed and developed and built our own heat exchangers, and when we took the dysfunctional ones out, we were left with these 5 units of, and if you looked at the pond, if you notice that sculptural thing that's sitting on the bank, that was the first one. And we sunk it to the deepest part of our pond, connected to our process loop. And so we took our hot process water to the pond. We could control in and out by temperature. So we, at the beginning, only wanted to leave 2 degrees in the pond because I was raising fish there. I had thought that a nice thing about the pond would be for the employees to go fishing. And so we were raising perch and carp and all these things to have a balanced pond. Since then, no one has ever fished in the pond, so the fish have lost priority, and that thermal 2 degrees saved 900,000 gallons of water. So what we were doing was making the job that much less by the time it got to the cooling tower, so that much less water. That was an epiphany. And so we maintained that system, but always tried how could we do more. And now if you look at the pond, that unit has been extracted a few weeks ago. The water is almost drained enough that they could install 2 enormous geothermal manifolds or units. And those will be sitting on the bottom of the pond. They're floating right now. But as soon as they're in the final position, they'll be filled with water, which will cause them to sink, and they will sit in the mud on the bottom of the pond. And now, if that one device, if you see it sitting out there, and you see the whole bottom of the pond coated with geothermal, imagine how much thermal we can put in or take out of the pond. Because it's a thermal dump in the summertime and a thermal opportunity in the wintertime. Because at the bottom of the pond, even at the top freezes, it's about 50 to 60 degrees in the mud. And so if we wanted to use a heat pump, rather than trying to get the energy out of 0 or 10 below 0 temperature, or 30 degrees even, in the wintertime, we have this constant supply of 50 to 60 degrees.
Wow.
And so on and on and on and on the saga goes. And every time we do this, and at the beginning, our employees thought that this was just a weird hobby. So finally my controller one year came up with a brilliant idea of how to impress on the employees. And we have a profit sharing program here. And when we present the profit sharing at the end of the year, one of our slides is how much of it came from energy that we didn't use or that we used efficiently. And so we keep track of, again, it's all economic provable and all bottom line positive impact. So we say which percentage of that profit came from the fact that we are getting 350,000 kilowatt hours a year from this wind turbine, or 1.6 megawatts of energy for free from this turbine, or the efficiency of our heating and our air conditioning from the combined heat and power. How much does that all add up to?
Wow, we need more people like you, I think, in my opinion. So I'll revisit that second question because I also love water. I live in Florida now, West Palm Beach area, and we do a lot, as much as we can, my family and myself, with conservation. So planting mangrove trees and cleanups all the time and that kind of thing. And speaking with Chris, he showed me this cool little plastic contraption that you have laid out all over that pond. And it was, I wanted to hear you talk more about it, but to my understanding, it's just kind of to give microorganisms and maybe other animals a place to create a home like a coral reef does. Is that
It is
kind of the
similar.
idea? And was just a more, maybe I don't know if better is a way, or more passionate way, or more care. It's a way to utilize plastic in another way, right?
It is, and so what we're doing there is called Cattail Remediation. When the parking lot, the roof runoff is no problem, but parking lot runoff has oil and salt and different contaminants in it. So if you're raising fish, you can't just take parking lot runoff into a pond that's a living habitat. And so the solution, traditional solution for that is called cattail remediation. So all of our drainage from the parking lots comes in one place where you see the intense location of those things. And so it has to pass through in the normal way that an environmental engineer would design it. They use dolomite, so or bank run gravel, so cobbles or small pieces of that, and to hold the roots of the cattails, but also to let the water flow through unrestricted. And what that does is it creates a habitat for the microorganisms that eat the parking lot salt and oil. And so the stones, if you look at a stone in that kind of situation, it will have a film over it. That film is living. It's creatures that are eating the salt and the oil. So what we did, dolomite takes energy to mine it, energy to transport it, so instead, we were at the time working with an environmental engineering company making a digester ball. So it was a ball that would, if you put it into sewage treatment plants, you could increase the volume of the sewage treatment plant without adding bricks and mortar, because by putting the balls in there, and they had much surface. The ball's task was to have as much surface area as it possibly could. So it was not really a ball. It was just a lot of flutes, and therefore an increase of surface area. So they literally build these 6x6 cages. They fill them up with digester balls and put them into the mix of the sewage treatment plant, and the increased amount of bugs is increased amount of flow that they can handle. So from that experience, we got thinking about, well, if we could make something like that, we wouldn't have to use the dolomite. And we have always been striving to do zero waste to landfill, even before there was a term. So we were always conscientious about, we had bug dust that molders would always tell everybody, oh, we don't have any waste, we grind it up and use it again. That's bull. If you're very, very lucky, you might find a customer who lets you put 10% of regrind in, and all the rest has to be virgin. So a plastics molder creates a lot of polymer waste, and it all goes to the landfill most of the time. So that bugged us too, and we wanted to, so we've always been very conscientious about how we do that. We maintain all of our regrind materials very carefully. We keep everything completely separated. And even but there's one part that we can't, because it's commingled. and it is the purges. And as a small company who does a lot of changeovers frequently, we create a lot of purges, because every time you put a new tool in, you got to change the material. Even if it's only a color change, you have to get that old material out and fill in the new and get the mold tested ready to go. So that creates a volume of material that is some combination of the last job and the new job. And so that was always the hardest thing for us to figure out what to do with. And we finally did with a plastic lumber company out of Canada. And we could take this purge, these different color parts and all that kind of stuff, grind them up, and for a very long time, several years, we were sending truckloads of that to Canada, and they were mingling it with low melt materials to create plastic lumber for industrial purposes. So it wasn't very pretty, but it outlasted lumber in constructing forms and things like that 10 times. Mm-hmm. So it was 10, the boards and that they nailed or screwed to would last 10 times longer than lumber alternative would. And that was going along greatly. And then everything was going to the right places. And one day the Canadian company called us and said, "Can't take your material anymore." I said, "Why?" "Well, our local molders found out what we were doing, and they said, 'Take ours, don't take it from Harbec.'" And so they did, and we lost our source. We helped a local company for a couple of years who got a franchise to do that same thing, but they had an unfortunate fire and put them out of business. And so we were stuck with this purge material. And from the things we learned about the media growing organisms, the need for the Cattail Remediation, so we developed our own solution, but we couldn't do a ball. And the reason why the ball wouldn't work is, if you think about it, the flow of water during a storm has turbulence, and it would have rolled all the balls to the bottom of the pond. Mm-hmm. So we learned from similar, what you're talking about, coral reefs, and actually the idea came from mine traps.
Okay.
In the World War II, they would have the concrete not mine traps, but the tank traps. And they would have the tank traps, that these structures that they would line them up. And there was no way the tank could get through, because the harder they pushed, the more they dug in. And that was the shape that we needed. We had the material that we needed, this mixture of who knows what. And so far we've been able to come up with 2 solutions, but not more than 2 yet. What the problem with the material is, because it's I don't know what plastic. And nobody today, except our 2 exceptions, wants I don't know what plastic. And so we have found a very bright idea, but very few applications. But the EcoStone is what we call that one, and that worked out quite well for us. And we've done now we give them away. We don't even make them anymore. But during the day when it was there and we were telling people about it and trying to promote it, we probably gave away to a half a dozen remediation projects. We would just say, if you bring a vehicle, we'll give you as many Gaylords as you want. But then it just kind of faded away. But that's where the original thing, the EcoStones, came from.
Creative. Bob, I could probably talk to you all day, or should I say listen to you all day about all this kind of stuff. But I'm going to go ahead and wrap up and just thank you for sharing this and doing what you do. And if you ever want to backpack Iceland with me, I've been there many times, and I get inspiration.
I want to go to Greenland
from there, and Greenland as well, Iceland, any of the Scandinavian countries. Yes. We can backpack around. I'd love to have you join me, because right now I'll go lay in a hot spring and I'll enjoy it, but I won't know the details like you do. So we can climb some volcanoes, we can watch some geysers, we can hang out in a hot spring. The invite is open, and thank you so much for sharing this story with MTD.
My pleasure.